Hello everyone, I am Ahmed Rockey Saikia, Engineering Physics third year in IIT Rockey. Today I will be presenting on the topic speed measurement using optocoupler as a part of my course Applied Instrumentation. The aim of this experiment is to study the performance of an optocoupler as a speed measurement sensor. The apparatus used throughout this experiment involves a speed measurement trainer kit, a cathode ray oscilloscope, an optocoupler, and a voltmeter. We will try to understand each of them in detail in the next slide. So, what is an optocoupler? An optocoupler is a device that consists of two circuits that are electrically isolated. So, one of the device consists of a light emitting diode and another consists of a photodiode. So, if the light transmitted from this LED is not obstructed by any medium, then this diode can detect this signal and can be used as a sensor. The next is a frequency counter. So, a frequency counter is a device that can measure the frequency of an input signal. So, how does it do it? So, a frequency counter combined with a time pulse, where we know the frequency of the pulse, can be used to count the number of pulses in a signal. So, as you can see, there is a signal conditioning unit that conditions the wave pulse into a rectangular waveform, and we have another accurate time base that is a clock whose frequency is known. So when we pass both of these signals through an AND gate, then what would happen is that for the given x hertz of this time, AND gate will produce the number of pulses that were active during this time. So the output of this AND gate will be the number of pulses that were active for a given amount of time. So this can be used to trigger a counter that can count the number of pulses in the signal, which can be outputted as a display. This is the speed measurement trainer kit. So the power supply to the motor can be controlled through this knob, which is then we have the sensor from the wave shaper, and the output can be seen in the CRO, the frequency of the output. The frequency is then multiplied by a factor of 4 in the next stage, which we can again see in the CRO. We will understand this reason in the calculation stage. This is then connected to a counter, and we have these two modes, speed and RPM, which we can use to calculate RPM and speed. To take the measurement, press reset the button and press the push to count button, which you can see, and take this reading for a period of 4 seconds. Now for the calculation. As we know, the diameter of the disc is 85 mm and the number of slots that are there in the optocoupler is 15. So the distance that it traverses in a single count of the pulse is equal to pi into diameter by 15. So now there are two ways to calculate the speed in millimeters per second. One is using the counter, another is through the RPM. So in the counter, we take a time source and we count the number of pulses that it passes through, and by multiplying it by the distance traveled in a single count, we can obtain the speed. Now for the RPM, if we know the RPM that can be obtained from the speed measurement trainer kit, we can multiply with the distance it traverses in a single revolution and a conversion factor from minute to seconds of 60. So the thing is, now why do we require that multiplier of 4 that I mentioned previously, is because a frequency counter is employed in the device. So whenever it wants to obtain the RPM, or when you toggle it to RPM, then the device just simply multiplies it by a factor of 4 and obtains this from the frequency counter. Now another interesting thing is that if we set the time is equal to 4 seconds when we are measuring using this counter, then what we can expect is that the number of counts should be almost equal to the RPM, which can be used for measuring the or recording the observation in a simplistic way. The following are the observation. So we take the measurement at different voltages of the DC motor. So the RPM can be measured simply by toggling the switch to RPM. The speed counter, here we have taken the time as 4 seconds. So we allow the speed counter to measure the counts for a period of 4 seconds. Then we calculate the speed from the speed counter, and the next is using the RPM. And we find that because of the using of this time of 4 seconds, the RPM value and the speed counter value almost match each other. Now we plot this speed millimeters per second for using both counter and RPM, and we find that there is a linear calibration with respect to the speed and the RPM counter. So now the precautions that we should take while performing this experiment is then the voltage of the DC motor should not exceed 3 volt. There should not be any delay while you are using the counter and the stopwatch to measure the number of pulses. Next is that all the connections should be tight. So these are the things that we should keep in mind while performing the experiment. So thank you, that's it.